Hi, Matthias Bohlen here. This video is about how to install a modern Python version on Windows, macOS or Linux. It was inspired by a question from my students of my software architecture for AI-based systems class. They said when preparing for your class, the Python installation on my machine didn't work. Okay, so I created this short video to help you. I will first talk about some outdated ways to install Python. So you will find a lot about this on the net still, like pip install and something. And there are much better ways to do this today. And then about the package manager. It's called UV. It's the most modern one since 2024. And it's a program that does all the installation stuff for you. And then we have 3 live demos, one for Windows, one for macOS, one for Linux. I will mark the chapters in this video so that you can jump directly ahead to the platform that applies to you. First of all, what were those outdated ways to install Python? We used to install Python, a certain version of it, and run all our Python projects on the same version of Python. It was only one local version per machine. And then we installed a package manager, things like pip, poetry, conda, and so on. And then we installed the dependencies. Each project had its own dependencies, like the other Python packages that you're using. The problem was pip installed all these packages into your main Python installation on the machine. So this made it bloated and non-reproducible. So the Python community invented virtual environments, so-called folders, where the Python interpreter was as an executable binary, and also all the installed packages, Python packages. You could have one such virtual environment per project, so you could keep your Python interpreters and project dependencies separate from the other projects. But all this required several CLI commands from Python until the version of the interpreter and the versions of the packages, they were compatible with each other. So this was not good. Today we have UV since 2024. It's written in Rust. It's a new package manager and it does all this stuff for you. It automatically creates a virtual environment. It installs the correct Python interpreter. And it installs the packages that your project needs. So it's pretty much plug and play, and it's fast, really fast. Let me do a demo of the installation using UV on 3 different operating systems. The basic installation flow is always the same. First we install Git, if you haven't got that. Then you install UV itself. Then you clone my test project that I will show you in a minute. It's open source on GitHub, so you can easily clone that. And then you run a Jupyter notebook just to prove that Python is working correctly on your machine now. So let's see what this looks like under Windows, under macOS and under Linux. So here's the first live demo, a Python install on Windows. Now I switch to my Windows mini PC here and I opened the Firefox browser on the GitHub repository so that you can follow along by opening the same repository. In the description of this video you will find the link to this GitHub repository. So if you arrive here, please click on how to install Python manually, because some of my students have said that they don't like Docker, or I should say their company doesn't like Docker. So today we are going to install Python without Docker. Don't worry, it's only 2 statements. So first of all, we need to install Git on the machine. I already did this because I thought this is not so interesting, might become boring for you. And what we're really going to get started with is installing UV. So you will find this shell prompt, this PowerShell prompt on the installation side of UV. And I'm going to copy it using this copy button here on the right side. It says copied. Now I will I'm going to open the cmd.exe prompt. That's a command line prompt under Windows, right? So I paste this prompt into the black window here using simply the right mouse button. Now I click the Enter key and PowerShell installs UV. It downloads it, expands it and puts it to disk. Okay, so I enter exit here because I need to restart the command shell so that uv.exe is now on the path. So it can be found. Let's test this. uv-version. Aha. uv 0.11.32 at the time of the recording of this video. Your mileage might vary here. Now we're going to proceed to the platform independent steps, which are down here. First of all, we need to clone this repository here so that we can test whether it works. So we clone this. Great. I change the directory into the cloned repository here. So we see here is the typical Git repository structure on disk. And I'm going into the 20 work here folder. See what's here. Aha, there's my Python project. So how are we going to proceed? We enter this magic statement here, uv sync --extra dev. I put this into the command line window as well. So now UV is downloading all the packages that this Python project needs, including a Python interpreter version, which also has been configured in pyproject.toml. You see here, when you look, you see this configuration file called pyproject.toml. Everything is specified there so that UV knows exactly what to download. Now this project should run. First we need two other packages, ipkernel and Jupyter Lab. Two packages that allow us to run the Jupyter Notebook. Yeah, that's better. So it's adding these two other modules. Okay, and now we can type uv run Jupyter Lab. So that's the command line to start the Jupyter Notebook server. A web server is started in this black window that you see here. It's coming up now, and it calls the browser automatically so that it points to my Jupyter Notebook server in the black window. Here you see the Jupyter Notebook itself. It's basically a big JSON file with so-called cells in it. Each cell can contain either text or code. First of all, I have got some text cells for you with some help explanatory text. And now we get to the more interesting part, the code cells. This cell that I clicked on here contains Python code. Now pay attention on the white space just below this cell. What happens when I click the run button here? Click. And you see that you get the output of the program right below the cell. If you save the notebook, the output will also be saved. That's pretty nice. So you can send the notebook to a colleague. So what we see here is that the Python path really points to the virtual environment that UV has created for us. The vn folder contains the Python interpreter and all the downloaded packages, which is pretty nice. Now let's go to the next code cell here, and this should plot a sine wave. Okay, I click on run. Takes a few seconds the first time, second time it goes much faster. And you see the sine function here. This proves that Python is doing its job on this machine now. The nice thing is that you can modify the code, let's say 3 times x, not sine of x, but sine of 3 times x. So when I click run, you see suddenly 3 sine waves instead of 1 sine wave. So it follows nicely directly the code that you enter there. It's immediately executed. Good. Now on this Windows PC, Python is working well, and we should go back to our Python installation on macOS. Okay, now I'm on my MacBook Air, and I opened the same repository so that you can follow along. The description of this video contains the link. So please open this on GitHub and then click on how to install Python manually. This was because of my student asked me, Docker is not allowed in our company. So yeah, let's do it without Docker. Here we see that I am using the Homebrew package manager that can install open source packages. So here we are using it to install Git and UV. We skip the Git installation. I've already done this, and we will focus on the UV installation. So I only need to have this string here, brew install UV. I go into a command line window, a terminal window on the Mac, and I paste the string here. I hit enter, and now Homebrew has installed the UV program. So let's try this. UV-version. Okay, the same UV version as on the Windows machine. And now we can continue with the platform independent steps. So let's go to the Jupyter Notebook test. So first of all, I should clone this repository here, so we can use it. Okay, it has already been cloned. So I go into 20 work here, and then I use this magic command, uv sync -- extra dev. So change directory to, first of all, into the Python Jupyter environment, then into 20 work here. Yeah, that's our Python project. Right. Here is this pyproject.toml configuration file. It contains all references to external packages which are needed. So UV, when we invoke it with uv sync -- extra dev, it takes all the dependencies, downloads and installs them together with a Python interpreter, an executable. And it also installs all those dependencies that are only used for development. This is the meaning of -- extra dev. So I hit enter here. UV is installing everything. Boom, already installed. So now let's proceed. I need 2 more modules to be able to execute Jupyter notebooks. So I add these 2 modules, ipykernel and Jupyter Lab. And now I'm running the Jupyter Lab itself inside this working directory here. So a web server is being started in this black command line window. You see it starting up here. And it invokes the browser again so that we can see our Jupyter notebook inside the browser. A Jupyter notebook is basically a big JSON file with lots of so-called cells. Each cell can contain either text or code. Here you see a lot of text cells, which should help you setting this stuff up. And the interesting cell is over here. It's a code cell. Now, if I click in this Run button over here at the top, pay attention to the white space down here below the code cell. Click. And you see here, you see the output of the program. Right. So this proves that the Python interpreter has been installed in this virtual environment subdirectory of this 20 work here folder where we're working into our project, which is pretty nice. Now let's scroll down to do something real. Here we have another code cell. It imports a plot library and plots a sine wave. So let's click on Run. Takes a few seconds for the first time. Okay, there's the sine wave. From now on, this works much faster. So let's try sine of 3 times x. Run. Boom. You've got 3 sine functions. 5 times x. Run. So we've got 5 sine functions. So sine waves, not sine functions, sine waves. So you see here that everything is running on this Mac platform now. And let's proceed to the Linux platform. Okay, let's go ahead and install UV on Linux so that we can run Python projects as well. I switch over to my Linux machine. I have opened the same GitHub repository as before. You can follow along by opening this repository also in your browser. So please click on how to install Python manually here on this link and go to the Linux specific section, this one. On my Linux machine there is already a Git installation, so I skipped this one. In case you have Debian, you can install it like this, and for the other distributions you will find it under this link here. So let's focus on the installation of UV, the Python package manager. So I'm going to copy and paste this prompt here. I go into a command line window under Linux. It's a bash shell. So I paste this statement here, and we see that UV is being downloaded from the net, and boom, everything is installed. So we can try this now. Let's close this window and open it once again. Let's make the font a little bigger. So we go to programming, UV -- version. Yeah, we have 0.11.32, same version as on the other platforms. So now we can go ahead to the Jupyter Notebook test, which is platform independent. So first of all, we clone this test repository here. So let's paste this into the command line window. And boom, the repository has been cloned. We can change our directory into it and into the 20 work here. So here we see our Python project. This pyproject.toml configuration file, by the way, it's the input for the UV package manager so that it knows exactly which modules to download or which packages to download. So we can now proceed and say UV sync -- extra-dev, which means synchronize all the Python packages that we need in our project to our disk. And as an extra, please also install the Python packages which are only needed during development time. So let's copy this. Then we go into the command line interface again and paste this. Boom. UV has already installed all those modules. Then we can go and add another 2 modules here. Paste. Okay. These 2 packages are needed to run Jupyter Notebooks, and I want to run such a notebook to prove that Python is working correctly on this platform too. So it has these 2 modules have been installed. Now we proceed with this last statement, and we put it paste. Okay, a web server is starting, and the Jupyter Notebook is being displayed here in the default browser. So I double click on Python sample environment here on the left side. Yeah. And you see here the content of the Jupyter Notebook. Jupyter notebooks are basically big JSON files which contain so-called cells. Every cell can contain text or it contains code. And here you see a lot of text cells that will help you getting this stuff set up. And here's the more interesting part. It's a code cell. It contains Python code, as you see here. And I can run this cell using this run button at the top. And pay attention to the white space after the code cell. When I click the run button, the white space fills with the output of the program. So here you see the Python version is slightly different than on the other platforms. And here you see the path in which the Python version has been installed. That's the so-called virtual environment, which is inside our project. Pretty nice. Now this proves that Python is basically running. Now we do something more interesting. Let's move to the next executable cell, code cell, this one. It sets up a plot package and plots a sine function. So let's run this. Takes a moment for the first time. Afterwards it's much faster. Yeah, you see here the sine function has been plotted. So from now on it's pretty fast. You can, for example, insert 3 times x here, run it again, and you see you've got 3 waves instead of 1 wave. So Python is working on this platform too. Now you're ready to join the club. You have Python running on your machine, hopefully, and now you can take my course on software architecture for AI-based systems, also known as SWOG for AI. You will find the course description under this link that you see here. The link is also in the description of the video below, so you can easily click it. And I would be happy to welcome you in one of my training classes like these. Thanks, bye-bye, Matthias.